I will be talking a little bit about Acurast. First, I'll give a brief introduction, and then we'll do a demo to see how it actually works in practice. So what is Acurast? Acurast is a decentralized serverless cloud, as mentioned, backed by mobile phones. So why do we do this? If we look at the global cloud market, you can actually see that about 99% of like all internet like websites, they are hosted by a few companies like Microsoft, Google, and Amazon. And there are a couple of issues with that. So first of all, you have like monopolistic pricing, you have lock-ins, and just arbitrary changes to the pricing that, well, you can't do anything about. There's also a problem with data ownership, confidentiality, and basically you just have to trust in the provider. And also the accessibility, because all three big companies, they're hosted in the US, and so there's censorship, and it's, well, not decentralized. So we are trying to change this by using mobile phones. So first of all, why mobile phones? So there's one, so here we can basically see why. Mobile phones have very powerful chips in them. Obviously, they have a CPU, but they also have a GPU for graphical tasks. They have a TPU for machine learning and AI tasks, and they have a security chip. So all of these features are part of every modern mobile phone, and this allows us to basically gain a couple of advantages over traditional hardware that is used in the big data centers. So let's take a look at the specifics. So for example, acquisition cost, you can see that if you buy a comparable kind of a server hardware, it is about 6 times more expensive than a mobile phone, like a Google Pixel. But if you take a look at the CPU performance, you can see that the performance is actually about the same, just looking at the CPU. But if you take the GPU and the TPU into account, you get around an 80% higher performance if you compare it to a standard server. Of course, there are specialized server like GPU instances, but they are way, way more expensive than the price tag that we see here. And then the last point is the energy cost. If we look at the kind of the watt usage, then mobile phones are way, way more efficient, which means that the running costs are way lower. So all of this combined basically gives us a reason why the mobile phones make sense as the kind of the backbone of a cloud. Now there is also one other important thing, which is we can do upcycling of old mobile phones. So of course you don't have to buy the latest and greatest flagship phone to participate in our network, but rather you can use an old phone that you have laying around and you don't really have a use for anymore, or you can even go out and buy broken phones. So if you do that, you can get way, way cheaper, kind of a way cheaper price tag to acquire the hardware and participate in our network. So if we take a look at the performance, there is also, well, we can see that the performance is also better on the Acurast network compared to the other cloud providers. In this example, we had a script that calculated the first 50 million prime numbers. And this is the raw execution time. So it doesn't take into account network latency or startup time. So this is really the raw kind of performance. And the reason for this is, again, because the cloud providers are not really transparent. So you don't know what the underlying server hardware is, or if you are sharing it with other people or processes. Whereas in Acurast, you know kind of which processor you get and the hardware that you get. So we can also see people are starting to build like small little mobile server farms. So they're buying old phones. Some of them, they don't even have a screen because all you need is kind of the working chip and a camera to do the setup process and one working display just to go through the setup. But after that, all you need is energy, power supply, and Wi-Fi to run the devices. Okay, so that's for the introduction, for the theoretical part. Are there any questions so far? Otherwise, I would go to the demo. Yes? No, not yet, but this is something that we're trying to achieve, because at the moment we have a working system. So you can join the network with mobile devices. You can create jobs that run on the mobile devices. We have a matching algorithm and everything. So the whole system works, but now we are investing into making it better, especially the developer tools. So we're working on a CLI, and we would like the CLI to be compatible with at least the most common functions of the other cloud providers. So you can do like an Acurast login to connect, and then you can do Acurast deploy to deploy it to our network. But that's currently not possible, but we're working on this. It's actually something that we're really working towards, because we want to kind of make the onboarding as easy as possible, especially for Web 2 people who do not know how like the Web 3 world works. Yes?
Yeah, I have a couple of questions. One is, when I see your project, I find it a bit like, maybe it's the inspiration, but it's like this SETI program where people seeded or lended computing power for the crypt or the crypto analyze the SETI program signals. I found a bit like this.
Fold at home kind of
Yeah,
thing.
this kind of you share your empty or your idle resources to compute, in this case science is. I found that is a bit similar in some aspect, and the other is related to the energy. I guess that the obvious question, obvious answer is, as you are using these low power devices, you can use just a big battery and solar panels and be totally green or 98% green in that sense, instead of the data centers that they are one of the most power and water consumer inventions of mankind in that sense. I think it's an interesting approach also, that this fills in a pocket, the data center doesn't fill in a pocket. So you can do it in very remote places also.
Yes, I mean, this is the last point, especially, is something that is also an advantage, which is the data centers. They're usually focused on the areas where most users are, but there are places on Earth where there are no data centers close by. For example, Africa, I don't think they have a lot of data centers there, but in our network, if we have a lot of people participating from Africa, we can actually reduce the latency within Africa by a lot, because those people can then kind of locally access the servers, and they don't have to do a round trip over like to Europe or some other place. Okay. Yes. So then let's move to the demo. First of all, I'd like to show you how you can onboard a new device and add it to the network. So the setup process is actually quite easy. This is the console that we have, our website, and you basically just need to, at the moment, create an account and download a wallet, connect it to the website, go to our faucet, get a couple of funds. I have a balance here already, and then I click here, add a new device. Then I have to sign something, and I get this QR code. Now I can use an old or any mobile phone, Android phone for now, let's see, and I factory reset it. After factory resetting, you can actually click the screen here a couple of times, and then you enter a special mode. Let's see. Yes. Yeah. So now the QR code reader opens, and I can scan this QR code. And now it asks me for the Wi-Fi. So now I have to connect it to the Wi-Fi, and it will automatically connect to our network, download the latest APK, all the configurations necessary, and basically the process will begin of setting up the phone. I will, because maybe also the Wi-Fi, I mean, it usually takes a couple of minutes to do the whole process, so I think I'll just leave it on the side and come back to it once it's done to show you how it looks afterwards. Okay. And maybe also just for later, we can see now I have 3 devices here. We can see when they checked in last. So one was today, one, that should actually be working. So I don't know, that went down. I have to restart it. And then one, I actually just didn't remove it yet because that's an old phone that I don't use anymore. So now here, back to the device, I have to go through a setup process, basically enrolling it in the network. So while this is ongoing, let's take a look at the other side. So this is what I just showed you is how to enroll a processor, how to become part of the network and provide compute power. And now we can take a look as a developer what you can do to actually post jobs, is what we call them, and run code. So for this demo, we will be deploying something that a code snippet that will then post the result on the Moonbeam or the Moonbase network. So here we have a couple of examples, example blockchains. The UI here is basically tailored towards blockchains, kind of an Oracle use case, but the code is actually not limited to blockchains. You can do any general purpose computation. So we select Moonbase here, then we have two example scripts. The default here is a price oracle, so we get the price from Binance API, we encode it and then send it to the RPC. But we will, in this case, use the verifiable random number generator to do that, to do the demo. So here, same thing, we get a random number from the device, and then we encode it and send it to the node, along with some information about the fees and so on. So then we go further, and we can configure some parameters of our job. So here we can first select which processor should run it. So either it can be a personal one, like one of mine, can be a specific one from someone else, or we can just use a public one. So we'll do that for now. Now we can say how many times and when this job should run. So in this case, we'll leave it at interval, and we say, okay, let's maybe start in like, wait, what time is it? So like in 10 minutes. Then run for, let's say, 1 hour. 15 minutes interval, let's change it to 5. So it runs 12 times. This is we can leave those at the default. We can select how many processors we want to deploy this to. We'll leave it at 1. And then how much I want to pay, like the fee that I want to pay for this job to be executed. So I'll enter a number here. I can see it's 12 times that because there are 12 executions. And then I can post this job to the network. Of course, I have to sign this message, and it will be sent to the network. So now we quickly have to wait here, because the transaction will be, once it's accepted on chain, we have a matching algorithm that matches the jobs and the parameters that I just entered here with the processors that are available. And then the matcher, we can see that the job has been registered. Now our matching is going on. So basically one specific processor will be assigned to do this job. That happened now. So now we're waiting for this random processor to acknowledge this assignment. And once he acknowledges it, he has to execute it in order to get the rewards. Okay, so this will take a little bit, but it shouldn't be too long. And going back to the phone, you won't see it in the stream, but this device is now all set up, and it's in kiosk mode, and it is now only running the Acurast software. You cannot do anything else with it. So if that was an actual processor, I would now plug it into power outlet and just leave it running, and it is part of the network and will earn rewards. So going back to the job creation, so we see now a specific processor has been assigned. So we can go here to the job details. We see again, like everything we entered before. We can also check the script that we deployed. Now, there is one important step that we have to do, because this is just because the result will be on Moonbase. So this processor that we randomly selected, it will not have any balance, any Moonbeam or Moonbase balance, which means the transaction will fail because of too little balance. So what we have to do is we actually have to take the address of this processor and give it a little some funds. So I will use the faucet here and make sure that this processor has funds. Oh, okay. I just tried it before, so that's why it looks like I'm blocked. Okay, so let me see. I actually probably have some here. Yeah, in any case, let me think if I have some Moonbase somewhere, but yeah, okay. So we can actually just we will see how the execution increases, but we will just not see the on-chain transaction because of the missing funds. But in the next part, I'll actually show how you can do a more interactive development style, because here, as we can see, like we have to wait 10 minutes, and this is actually, well, it's not great for especially during the debugging phase. So we actually introduced a feature that we call live code, which let me select the script again. So with the live coding feature, you can deploy a specific script that we provide to a processor that will then allow you to use that processor to on demand send a code snippet to it, execute it, and get the error or success result back immediately without having to wait these like 5-10 minutes every time. So in this case, I have a processor set up here that is connected to this front end, so I can run the code right now. So if I here I have this already set up, and I can run it. So usually one thing is when you are in Wi-Fi's like this, it's possible that this debug version actually disconnects, which is why I have to go here and restart the process. Okay, so let me refresh here. And let's try again. Okay, so now we can already see that this script actually has an error, which, yeah, obviously this should be payload. So let's see. So I'll have to update that afterwards. And if we run it now, this can be ignored. That's just kind of an internal behavior. We'll have to remove that. But we can see that it succeeded. And if we check the block explorer, we should now see this. Let's go back. See this transaction on chain. Yes. So now this is now basically what I did now is what you would use for debugging, because you can play around, you will see the error messages. But then once you are happy with the script, which I now basically deployed a job that had a bug in it, so it will definitely not work. But after you see that it works, then you can deploy it as a job that runs in a specific interval as shown in the beginning. Yes. So now let's take a look at the devices. And as we can see here, we now have 4 devices. So this device is now actively participating in the network. And we can see that it has, so this is probably the new one. And it reported, or maybe this one. Ah, yes, this is the new one, which reported back about 5 minutes ago. And it will send a heartbeat every 15 minutes to show that it's still here. Yes, so I think that's it for the demo part. So sadly, because of the missing, because of the missing faucet, that we cannot see how the job will post the result, but it will behave just like the live coding example that you've seen. Yes, so thanks a lot for listening.